Primarily, the way that I've been starting with the standards is, like I said earlier, from the teaching point. I started out by going to quite a few of the webinars that NSTA offered, and I also got to hear Steve Pruitt, I believe, Stephen Pruitt from Achieve, who he shared at I went to one of the regional NSTA conferences, and he shared a lot about what Jennifer and both Sean have talked about in terms of how the process went and what has happened. And I even blogged after I listened to him, and that blog is located on our website, but no big deal there. But the piece that really stood out to me was that these were performance standards. In Kentucky, primarily, we were all focused on content, and so we had a lot of content standards. And I saw that as a big improvement as we moved into performance standards, because in many cases I felt we were losing the process skills that are so important to science, and is what science is about. Science is about doing in my book, and performance standards take us there. So that was the biggest thing that I heard from Steve that day as he began to share how the standards were developed and how they were different. So that's where I took my lead from. You want to add to that?
Sure. Well, an interesting follow-up might be that about 10 years ago, Stephen Pruitt was the state's science program manager here in Georgia, and he convened a panel here in Georgia to write our performance standards. And I worked with him on that, and then later joined him as a staff member at the Georgia Department of Education. So we had been through this process in Georgia with the same leader that the national process has had. So it gives me maybe a bit of insight into how Dr. Pruitt has worked through this process. And in my current role as the Professional Development Director for NSTA, I've been trying to figure out what NSTA resources might be helpful to teachers. And first of all, I certainly recommend that teachers, administrators, science coordinators, anyone who's trying to understand NGSS, start by going back to the framework for K-12 science education, and study that document first. And then if you are interested in a guide for that, NSTA has this book, which is a guide to the frameworks. There are also some other newer NSTA publications that are guides or different types of tools to use with NGSS itself. One that's really helpful for teachers is Translating the NGSS for Classroom Instruction. This one is really new from NSTA, and it gives lots of examples of looking at the new standards and giving examples of how they can actually be translated into classroom use, what type of lesson we might use. And so Drew had mentioned my books, both on outdoor science, and the latest one is Bringing Outdoor Science In, and one of the lessons that I've got in this book is how humans use rocks. And when I was looking at when I was writing this book, we were at a point where we had the framework and some early drafts of standards, but we weren't at a point that I could actually use them. But I had an idea from the framework what we might be looking at. So I was considering what ended up being these cross-cutting concepts and looking a lot at structure and function. And as a life scientist, I found it interesting to take some of the kind of engineering concepts that are included in NGSS and apply those to life science performance standards, and to think about how nature sometimes inspires engineers. There's an interesting book for, it's kind of a middle school level book for students, maybe early high school, called Biomimicry, and it's fascinating and helps students understand the design in nature, and then how the engineered world often takes its lead from a natural type of design. So in these lessons in this book, that's kind of what I've tried to capture. And I think that in looking at the NGSS, the cross-cutting concepts are really one of the important features for teachers and administrators to look at.
I have
Go ahead, Denise.
one small comment, because I really like that he's mentioned the engineering. I think putting that in the forefront for all of us as teachers to be thinking about is very important. And the one thing that stands out to me when it comes to the engineering piece is it's the so what and what if for kids. They always ask us, you know, oh, well, why do we have to know this? Well, let's think about it. Let's figure it out. So what? So we've done this now. Let's go on. And I think that was forgotten a lot. We didn't always go that place. And I think it's really important that we're going there now. These are big connections that we're making for kids.